All right, it's going to be a quick one. Just number 19. You want to create an upright image that's magnified by a factor of 3 in order to view some fine details on an old photograph. So we want to magnify upright. What kind of lens would you use? Well, magnifying glass would be a convex lens. Um, Concave or diverging will make things smaller all the time. All right, so you want to place the photograph 10 centimeters from the lens in order to get an image that's 3 times. Calculate the distance the image will appear from the lens if the object is 10 centimeters from the lens. All right, so we want a magnification and we have the distance we want, so we could find the actual size. It was 3 times as big. Well, it's probably going to be about 30 centimeters, but let's calculate it just in case. So that's what magnification is. Magnification is how many times bigger or smaller is it? So if it's 10 or far away. So if it's 10, then it's going to end up being 30. But magnification equals negative di over do. And so we want the object. So if I want the magnification to be 3, then actually I want the magnification to be 3, then I need to have a negative di over 10. So 10 times 30 is let's see, 10 sorry, 10 times 3 is 30. So I have 30 equals negative di, or di equals negative 30. Sorry, I was stuck there on what the negative, but the negative, right? Di being negative tells you that the image is on the same side as the object. So that's what negative 30 is there. So it'll be 30 centimeters. And so that's how big it will be. All right. And then what focal length must that lens be if it's producing that? Well, 1 over the focal length is going to equal 1 over di plus 1 over do. And so 1 over the focal length is 1 over negative 30 plus 1 over 10. And that's going to be 1 over f equals positive 0.06, repeating. And then again, you do the calculator button and you'll get focal length equals 15 centimeters. So I need it to be 15 centimeters. Again, like I said, a quick one, but then I want to put the lens diagrams in the same one.